Okay, so find the inverse of the function and state the domain and range. So our original function is a cosine function here, and we're going to be working with finding the inverse. So it might be easiest to just state the domain and range first. Here, the domain of cosine is negative infinity to infinity. The range here, it's reflected over the x-axis, which is not going to change the range. It's moved up 2, so the center of our cosine graph is at 2. And then the amplitude is 4. So what helps me is like kind of do a little sketch. If the center of my graph is at 2, I'm going to go up 4 from there. 1, 2, 3, 4. So 2, 3, 4, 5, 6. And I'm going to go down 4 from there. 1, 2, 3, 4. So 1, 0, negative 1, negative 2. So my range, my cosine graph, would do something like that. And it would go from negative 2 to 6. Now the good thing about that is that range gives us our domain of our inverse. So now the hard part, the only part that we really have to work for here for the domain and range is finding the range with the inverse, and we'll work through that at the end. So in order to find the inverse, we're going to change our f of x to y equals, switch x and y, and now we're going to solve for y. So the first thing I'm going to do is I'm going to subtract 2 over. And then I'm going to divide by that negative 4 on both sides. I like to not have a negative in my denominator, so I'm going to distribute it through the top. You don't have to do that if you don't want to. It's equivalent to leave that negative in the bottom. And now here's the most important step. In order to move that cosine, to get rid of it, we have to take the inverse. That's this whole unit, so hopefully that's easy to remember at this point. The way we get rid of cosine is to use arc cosine, or cosine to the negative 1. Just like multiplication and division undo each other, just like logarithms and exponentials undo each other, cosine and arc cosine undo each other. And now I'm going to divide both sides by 2. The way I'm going to write my final answer is going to help me with the range. I'm going to write it as a 1/2 out front. Divide by 2 is the same as multiply by 1/2. So there's my inverse, just some algebra to get there. The only new step this unit was using the inverse of cosine. Now, for the range, we have to know what the range of the original function is in order to find the range of our transformation of the inverse here. So if we flip back to the very first slide that we did, our original cosine graph, the range is 0 to pi, right here. Our original cosine graph, the range is from 0 to pi. So now, the transformations here, I'm going to write that down. So if we're just graphing y equals cosine to the negative 1 of x, the range is from 0 to pi, including the endpoints. Now let's look at our new equation of 1/2 cosine to the negative 1 of that mess there, and see what is going to impact our range. Well, all the stuff in the parentheses, those are horizontal changes that are happening to our cosine graph. So the only thing that impacts our range here is this 1/2 out front. That's a vertical shrink by 1/2. our range going from 0 to pi, we would multiply both of these by 1/2. Well, 0 times 1/2 is just 0. And pi times 1/2 is pi over 2. So my new range is 0 to pi over 2. So remember, this is a special case where our original domain doesn't just become our range here. That's not what happens, because our original function, in order to have an inverse, we had to clip it down. Really, what we did was we clipped it down to just 0 to pi over 2. That is the portion of that original function that we would flip to find an inverse. So that's probably the trickiest part of the whole entire test. Here is probably this range piece right here. Just remembering to multiply it by whatever number you have out in front of either cosine or sine. Now, if this had been a sine problem instead of cosine, then your range for sine is negative pi over 2 to pi over 2. So that's what we would be multiplying. If we were doing by 1/2 there, it'd be negative pi over 4 to pi over 4. Just so you've seen another sine example in case you were to need to do that on the test. All right, that's fine.